for you so you can do that while I'm talking. We're not actually going to graph today. We're going to analyze graphs of power functions and polynomial functions. So these are higher power stuff. Also this week involves some factoring, so do not let that escape your brain. But it is factoring higher powered polynomials. So we're applying old skills to that. Just a little bit different. But today we're going to focus on degree and end behavior. So a power function is any function of the form f of x or y equals a times x to the nth power. A and n are non-zero real numbers. Okay. They're also positive to be a polynomial function. But for a power function, a is the leading coefficient, and that is the coefficient of the largest exponent term. We're going to use that today too. And n is the degree, which is the value of the exponent. So a power function is anything with an exponent, essentially, a positive exponent on the variable. A power function with a positive integer n is called a monomial function. Now, in Unit 1, back in August, end behavior was discussed, but a lot of people struggled with it. So this section does a little bit better job of going into specific ones, because I should be able to give you a function without a picture of a graph, and you should be able to tell me what the end behavior is based on the degree. So as I go through this, I'm going to make a couple notes here and there. I encourage you to do the same. I'm going to actually do the first column, so we're going to stick with top left, then we're going to go down here and then come back up, because they have similar qualities. So do you guys at least remember end behavior being the infinities and something involving them? That's a tough thing to learn right off the bat, so we'll probably rethink that next year. So with these, so you'll notice the first column, this one and the one below it, they are even powers. So it can be any function at all, but we have an x to the fourth power, so the degree is even. So 2, 4, 6, 8, those are all even numbers. 1, 3, 5, and so on would be all odd numbers. So if it's even, your focus is on the arrows at the end. So it doesn't matter what's happening in the middle, but the arrows on the end would be the end behavior. That is determined by if the leading coefficient is positive or not, positive or negative. Now 1/4 would be the leading coefficient, that's a positive number, there's no negative sign. So if the highest degree is even, which is where the 4 is, and then it's positive, both arrows on the ends are going to go up. So if you want to make a note to yourself, that will actually help you later. So if it's even, both arrows go the same direction. If it's even and the leading coefficient, which is 1/4 in this case, is positive, they're going to go up. Now what that means is both the left arrow and the right arrow are going up. So this is how we would write this. As x approaches negative infinity means as it goes to the left, f of x approaches positive infinity. So in layman's terms, what this means is the left side of the graph is going up. Is that true? Left side of the graph is going up. Now the right side of the graph is also going up. So that's as x approaches a positive infinity, going to the right, f of x or y is also going up. So this means right and up. Okay. So if it's an even power, they're either both going up or both going down, depending on if the leading coefficient is negative. If it's going up for both of these, regardless, domain is always all real numbers. That was on your test yesterday. Okay, we did quadratics, those are even powers. If they open up the range, so in your homework you'll have to do this, it's all real numbers greater than or equal to 0, or whatever the minimum is. Okay. For today, they all should be 0 if that's the case. All right. So the main thing here I want you to take away, if the degree is even, the arrows go the same direction. Either both up or both down. They are both up if the leading coefficient is positive. Okay. We're going to practice with this a little bit. Now going down here, degree is still even, so this is negative x squared, so still even degree, but now the leading coefficient is negative, so that would be a -1 technically. So that means both arrows are going down, but they're still going the same direction. So what this is saying, so our end behavior, as the graph goes to the left, the f of x values or y values are going down. As x approaches positive infinity, going to the right, also going down. So this is left, right, down, down. Okay. The other one was left, right, up, up. This one, domain is still all real numbers, but the range flips. It's all real numbers less than or equal to 0 because that's a maximum instead of a minimum. Okay. So the even ones, the arrows are going the same direction, and it just depends on whether the leading coefficient is positive or negative. Any questions on that? Okay. Now the odd ones, they're not going the same direction. One's going up, one's going down. It just depends on whether the coefficient's positive or negative. So if it's odd, so x to the 5th, for instance, is odd. X to the 3rd is odd. Even x to the 1st, that would be a straight line. That's odd. They just go opposite directions. So if the leading coefficient is positive, you'll see this down here. It goes down on the left and up on the right. So down and then up. So as x goes to the left, the graph is also going down. So this is left and down, up, or sorry, right and up. On these odd ones, very easy. Domain and range are all real numbers because it goes forever left, forever right, forever up, and forever down. These ones with the even ones have limitations on it. All right. What changes with this one? It flipped. Why? This one is up and then down because why? The leading coefficient is negative. That's a negative x to the 3rd. So the x to the 3rd means opposite directions, but it's just which one's up and which one's down. So this means left and up, right and down. Domain and range are still both all real numbers when it's odd. Does that help a little bit with end behavior? Now you're not always going to be given a graph. It's going to give you a function, so that's why you need to know even ones go the same direction, either both up or both down. Odd ones go opposite directions. It's either down to up or up to down. So that you need to know, and that's dependent on whether it's negative or positive. So I would actually encourage you with all the ones in your homework, because you won't have pictures for those, maybe give yourself a little key, both arrows up, both arrows down, or up, down, down, up, depending. Okay. So we're going to practice with this, but if you need this chart for your homework, that's why I printed it for you. Okay. So we're going to start that for this first example. So it's just going to give you a function. In your homework, you would need to copy this down, so make sure that you do that. Okay. If it's a graph, you don't have to copy it, but if it's a function, you do. So we're going to describe the end behavior of f of x equals negative 2x to the 3rd using the leading coefficient and degree, and state the domain and range. Okay. What is the leading coefficient on this one? It's negative 2. So it's a negative number. What's the degree? It's 3. And what type of number is 3? Odd or even? It's an odd number. Okay. So if it's odd, that means they're going opposite directions. Now if it's negative and odd, what are the arrows doing? Up, down, or down, up? Up and then down. Okay. If it's positive coefficient, it goes down first, then up, so it should rise from left to right. This one, the graph is falling. It will squiggle a little bit, but it's falling overall from left to right. Okay. So the order, I went ahead and typed this out for you, but make sure when you're writing, you always go as x goes to the left, which is negative infinity. What's the left arrow doing? We drew it up here, so it's going up, positive infinity. And as x goes to the right, meaning approaching positive infinity, what's f of x doing? Negative infinity. So if you struggled with this previously, you always start with as x goes to the left and as x goes to the right, then describe either up or down, depending on it. Okay. Positive infinity or negative infinity. What's the domain? All real numbers. Now that's no matter what. Okay. What's the range? If it's an odd degree, it's all real numbers automatically. If it's even, it'll be depending on if it's positive or negative, it'll be all values greater than or equal to 0 or less than or equal to 0, because you'll only have a single term. Now, the only thing that changes here is, so still odd degree, if that was a positive 2, it would go down, up in that order. Okay. So very basic memorization would be knowing which one's up, down, and which one's down, up, which one's up, up, and which one's down, down. Okay. If you can do that, you should be okay. All right, but use the chart to help you with that. Any questions? Because the rest of the time we're not talking about end behavior. I might ask you for it. But. So the first 4 in your homework are like this. All right, so just FYI there. All right, so what we're talking about next is in terms of degree and leading coefficients a little bit more. So a polynomial function is a continuous function, meaning it's not broken, it keeps going even if it squiggles. And that can be described by a polynomial equation in one variable. The terms should be written in order from greatest to least degree. So descending order, okay, highest exponent to lowest exponent. That is standard form. The degree of the polynomial is the degree of the term with the greatest or largest degree. So the degree of the whole equation is the largest one. Okay. So what we just did, it was the degree of the whole thing. It was just one term. But it doesn't matter if it's one term or 5 terms. It's the largest one determines the degree of the whole thing. So this chart includes several examples. When the degree is 0, meaning that the exponent of x is 0, if you remember that from Algebra 1, 2, anything to the 0 power is 1. So that is why constants, meaning numbers, they don't have a variable attached, because the 0 technically eliminates the x attached to it. A linear function has a degree of 1, so an x to the first power. It's a straight line that either goes down, up, or up, down. Okay, diagonal line. We just did quadratics. That's when the highest power is x squared. Cubic functions, we did a little bit in terms of factoring, but we didn't really graph them. That's when the highest value is 3. So if you notice, these are all highest to lowest power. Quartic is when there's 4. A degree of 4 is the highest, and then quintic would be 5. Anything higher than that doesn't really have a special name, but we won't really deal with ones higher than that. So these ones, since they're the largest, and these are all in descending order already, these determine what the degree of the whole equation is. And it doesn't matter if it's a 5th degree and then there's only 2 terms. If that's the highest, that determines the whole degree. Okay. Bless you. So as of right now, you don't really need to know the names. You might be asked for that later, though. So I wanted to at least give it to you somewhere. Okay. So we're going to use that just to determine the degree and leading coefficient of these polynomials in one variable. If it is not a polynomial in one variable, do you have to miss notes right now?
I have to go to the bathroom.
Okay. Hurry up. If it's not a polynomial in one variable, make sure to explain why, and I'll give you a couple explanations. So is this a polynomial in one variable? What's a variable? Is there only one letter being used? Yes. Okay. Is it in descending order already? Highest exponent to lowest exponent. Yes. Okay. So that means this term determines the whole thing. So this is the term that we're paying attention to. So in your homework, if you're given these equations, make sure to write them all down. What's the degree of the whole thing? 4, because that's the largest one. So this one has a degree of 4. The leading coefficient is the large number in front of that term. So what would that be? Leading coefficient would be 2. That's all I'm asking you for right now. Okay. What about B? Is a degree of 3, or you'd say 3rd degree if you want to. What's leading coefficient? 7. C? 5. What's the leading coefficient?
12.
What number's in front of that? If it doesn't have to be written, it's 1. Any questions so far? So the largest one determines both of these. Okay. About D. Is that a polynomial in one variable? No, why not? Because it has variables x and y. That is your explanation. If you say that, so if it's, you would say this is not a polynomial in one variable, so just like it's worded in the polynomial, just like it's worded in the question. Because you have x and y. So something along those lines. It might be A and B in your homework. Okay. As soon as it's not one variable, you need to list it. So we wouldn't even determine degree. Okay. Now, is E a polynomial in one variable? Yes. However, it's not technically a polynomial. What's weird about it? The fraction part of it. The fact that the fraction has a variable in the denominator, that creates an issue. Okay. So what this actually is, if I were to rewrite it with an exponent, this would actually look like this. Negative 6x to the negative first power, but you should never have negative exponents. So what that does, it's already been done for you. This, with its base, drops down below to become positive. You did this in Algebra 1, 2 as well. So it's not specific to the one above it, but this is just flat out not a polynomial. Okay. So not a polynomial. Okay. And your reasoning would be because the 6 over x term, or negative 6 over x term, has a negative exponent. Okay. Any exponent in the denominator does not determine a polynomial. So positive exponents only. 0 is fine because that would be just a constant, like this 4 right here in problem C that has an exponent of 0. So this comes up in your homework. It's a polynomial in one variable, but it's just flat out not an actual polynomial because of that negative exponent. It has to be a positive exponent to be a polynomial. Otherwise, it's technically 2 of them put together. Any questions? Liam?
So we're gonna have problems that are gonna make us like move up the fraction and then tell it's polynomial.
So you didn't have to do this. I'm just explaining where the negative comes from because it's obviously not visible at that point, but that's why the x is on the bottom. Because technically this is in descending order, but it's not a polynomial with an x on the denominator. This would actually be one that we're going to get to probably into next week or the week after. We'll get answers that look like this, but it's not a polynomial. It's just a result of a division problem.
So the degree should never be negative, like either.
Degree should not be negative in any term. Okay. So if you see a fraction with a variable on the bottom, not a polynomial. It's technically 2. Okay. Question on that part? Make sure if these are the ones in your homework, these are actually 7 through 12. Copy the equation down. Okay. I need to know what you're looking at. Questions before we do the last part? Okay. On the graphing ones in your homework, you do not have to copy down the graph unless you want to. Okay. Now, what we're finishing with, I'm just going to add one more thing to it. You don't have to do that in your homework particularly, but we'll have to do it tomorrow. So use the graph to state the number of real zeros of the function. What's a 0? It's an x-intercept. So how many times does this graph cross the x-axis? 3. Okay, so we would say, so it's right here, and right here. Alright, so for today, in your homework, you just need to tell me there's 3 real zeros. It may have imaginary zeros. We'll determine that later. Okay, but those won't be visible anyway. But 3 real zeros. Now, just for practice sake, what are they? -2, +1, and +4. We're gonna need to pick these out of a picture tomorrow, so I'm just tacking that on. You do not have to do this in your homework. You actually won't be able to tell. There's no grid lines on the ones on your homework. What about G? How many? 4. So it's 4 real zeros. You can even say real roots if you want. It's the same thing. Where at?
-5, -3, +3,
What type of degree is this one? Odd or even? Odd, positive, or negative leading coefficient? Going down to up. What does that mean? Positive. What's this one? Is it odd or even degree? Even. And positive because they're going up. Okay. Those you had pictures, just for practice sake. What would this one look like? If the highest degree was 4. Those would both be up because it's positive and it's an even degree. What's this one? It's odd. So is it down then up or up then down? If it's positive, it's down first. It rises from left to right. What about C? Same thing. It's positive, so it's down to up. This one? This one, it would look a little different. Let's say it was just X's, it would be both up. This one, regardless of this, would be what? Down and up. Okay. That make it a little bit easier. Okay. The more you practice with those, I would actually recommend you draw these little arrows for yourself because you won't have pictures. And that'll help you with the negative infinities versus positive infinities. So your homework